The following video is on operations with vectors. And the operations with vectors, a lot of the operations are similar to what the operations you'd use for variables and numbers. So let's just dive into this. So let's look at 1D. I have vector q plus this scalar of 2 times this vector of x equals vector r. Now if I'm trying to solve for x, I'm going to subtract q from both sides, and that's going to give me 2x equals r minus q. Now normally I would divide by 2, but if I have some vector divided by 2, this has no meaning in vector space. No meaning. So instead of dividing by 2, I'm going to multiply it by 1/2. So I get x equals 1/2 times r, the quantity of r minus q. So there you go. If we look at the next one, we're solving for x. So I am going to subtract rs from both sides, 4s from both sides. That gives me 5x equals t minus 4s. And again, I cannot divide by 5, so I'm going to multiply it by 1/5. That gives me x equals 1/5 times t minus 4s. There you go. Let's do one more, solving for x. I'm going to subtract 4m from both sides. That gives me negative 1/3 x equals n minus 4m. I'm going to multiply both sides by negative 3. That gives me x equals negative 3 times the quantity of n minus 4m. Let's look at 2b. Now I'm given the vectors. Instead of just using variables to represent the vectors, I have the full vectors here. So I have 3x minus a, which is negative 1, 2, 3. And I have 2b, which is 2 minus 2, 1. And I'm solving for x. So the first step is I have these scalars. I'm going to take care of these scalars. That's going to give me 3x and then plus 1, negative 2, and negative 3. And then that equals 4, negative 4, 2. And then I'm going to subtract this vector from both sides. It's going to give me 3x equals, and then I have 4, negative 4, 2, and I'm subtracting 1, negative 2, negative 3. To get 4 minus 1, that is 3. Negative 4 minus negative 2, that's going to be a positive 2. So I have negative 4 plus 2, that is negative 2. And then 2 minus negative 3, that's 2 plus 3, that is 5. So there you go. This is my, I'm sorry, I'm not done yet. This vector equals 3x. So I'm not going to divide by 3, I'm multiplying by 1/3. So that gives me that x equals, x equals 1, x equals 1, negative 2/3, and 5/3. So there we go. This is what x equals. X equals this vector here. Okay. Number 3. I have a vector OA, which is negative 2, negative 1, 1, and I have another vector OB, which is 1, 3, negative 1, and I want to find vector A to B. Now, O represents that the tail of our vector is at the origin and the head of our vector is at some point. Well, if our tail is at the origin, then, and this is our vector where we go a certain number of spaces in the x direction, the y direction, and the z direction, we're going to have some vector, if this is the origin right here, some vector here with a point. Our point is going to be at A, negative 2, negative 1, 1. And the only reason I know this is because I'm starting at the origin. If I'm starting at the origin and I go a certain number of spaces, then this is actually going to be the point here of A. We're going to do the same thing with B. B is going to be somewhere out here with a point at 1, 3, negative 1. So if I want to find this new vector from A, this is my B, my point B, then I'm looking at this vector here. So the way that we find a vector between 2 points is we take the head of the vector minus the tail of the vector. So that would be 1, 3, negative 1, and then minus the tail, negative 2, negative 1, and 1. So our new vector of AB is going to be 1 minus negative 2, which is 3, and 3 minus negative 1, which is going to be 4. And then I have negative 1 minus 1, which is going to give me negative 2. So this is my vector. But here it says, hence, that I have to find the distance from A to B. Well, the distance from A to B is just the magnitude of this vector. So if I can find the magnitude of this vector, and the way we find the magnitude of the vector is by taking the square root of 3 squared plus 4 squared plus negative 2 squared. 3 squared is 9 plus 4 squared, which is 16, plus negative 2 squared, which is going to be 4. And then 16 plus 4 is 20. 20 plus 9 is going to give us 29. So we have the square root of 29, and this is a distance, so some units. I don't know what the units are. Moving on, we do have a lot of problems to go through, so I'm going to skip 4. Let's look at 5. So I have negative 3 times the magnitude of vector b. Well, the magnitude of vector b is negative 2 squared plus 1 squared plus 1 squared, which is negative 3 times the square root of negative 2 squared is 4 plus 1 plus 1. We add those up, I get negative 3 times the square root of 4, 5, 6, 6. So I get negative 3 times the square root of 6. The next one, I have the scalar of negative 3, and I'm going to multiply it by our vector of 2, negative 2, 1, 1. And then I'm going to find the magnitude of all of this. Well, let's first multiply our scalar to get negative 3 times negative 2 gives us a 6, negative 3, negative 3. And then we need to find the magnitude of this. So the magnitude is going to be the square root of 6 squared plus negative 3 squared plus 3 squared. 6 squared is 36. Negative 3 squared is 9, and we have another 9 here. 36 plus 9 is going to give us 45, and 45 plus 9 is going to give us 54. So I have the square root of 54. So this is the square root of 54. Now, I feel a little uncomfortable with this only because the square root of 54 is clearly not simplified. So I am going to simplify this. It might go off the page, so I'm going to use additional paper. So a factor tree, 54 is even, so it's divisible by 2. That gives me 2 times 25, 26, 27 will give me 54. And then 9 times 3 will give me 27, and then 3 times 3 is going to give me 9. I have a group of 3's that can be pulled out of the square root, so that's going to give me 3 on the outside. And this 2 never had a partner, this other 3 never had a partner, so inside of the square root we still have the 6, which, looks the same as e. So the only difference is that what we have here is a positive 3 because the negative 3 is inside of our absolute values. But one of the properties, operations that we have of vectors is that if I have some k scalar, and let's take the magnitude of the scalar times some vector, say vector a, then we're going to get the same answer as if we just take the magnitude of our scalar a, k, times our vector a. We're going to get the same answer. So in fact, what we should have found up here is if I have the magnitude of negative 3 times our vector of b, we should have gotten the same thing as if we multiplied or we found the magnitude of negative 3b. All right, let's look at G. I have the magnitude of a plus b. A is 1, 0, 3, and I'm going to add it to b, which is going to add it add it to b, which is negative 2, 1, 1, to get negative 2, 1, 3 plus 1 is 4. But now I want to find the magnitude of this vector. And the magnitude of this vector, well, let's make sure we have enough room. So we have the square root of negative 2 squared plus 1 squared plus 4 squared. Negative 2 squared is 4 plus 1 plus 16. 16 plus 1 is 17 plus another 4 is 21. So we end up getting the square root of 21 for 5g. Now we could also do, well, I'm actually curious to know whether I did that right or not. My notes say that I didn't, so I'm going to just look back at it really quick. So I added these vectors here to get negative, right there. 1 plus negative 2 should have given me negative 1. So there we go. There's the mistake I made. I'm just going a little bit too fast. So 1 minus 2 gives me negative 1, 1, and 4. So I should have had a negative 1 here, which would give me 1 here, 16, 17, 18. That gives me 18. So I have the square root of 18, but the square root of 18, we can do a factor tree for that. That gives me 2 times 9, and 3 times 3 gives me 9. I have a group of 3's that can be taken out of the square root, so I end up with 3 times the square root of 2, which is the answer. All right, moving on. It looks like we've spent a lot of time and we really haven't progressed very far, so we're going to have to pick up the pace a little bit. So for number 6, I have a vector AB, which is I, negative j plus k, and vector BC. So I have some vector here, A to B, another vector from B to C, and I want to find this resultant vector in terms of ijk here. Now we can see that from the red vectors, the red vectors, the first vector would take me here, and then the second vector would take me here, which would be the same results as if this new vector here, the green vector, was applying on my sailboat. So we're really just looking at adding these two vectors together to get this new resultant vector. So we're going to add our I values. I have I minus 2i, which is going to give me negative I. And then I have negative j plus j, which is going to give me 0 j's. And then I have k minus 3k, which is going to give me negative 2k. So there you go. That is the answer for number 6. Moving on to number 8, it says find the coordinates of C, D, and E. So I want to find, if we can see that from A to B and B to C and C to D, these little dashes here indicate that these distances are all equal. So I'm going to find this vector here from A to B, and if I take that vector and I just add it to B and then add it to C, it'll find these missing values here. So I'm going to find this vector here from A to B. Now I have 2 points, so we're just going to use our technique of head minus tail. The head of our vector is 2, 3, negative 3, and we're going to subtract we're going to subtract point A, which is negative 1, 5, and 2. That's going to give me 2 minus negative 1, which is 3. 3 minus 5, negative 2. And then I have negative 3 minus 2, which is negative 5. Right? So I have this new vector here. I'm going to add it. I'm going to add it to B. So I have 3 plus 2, which is 5. Negative 2 plus 3, which is 1. Negative 5 minus 3, which is negative 8. Okay, we're going to take that point and add our vector again to it. So I have 5 plus 3, which is going to give me 8. Negative 2 plus 1 is going to give me negative 1. And negative 5 minus 8 gives me negative 13. Negative 13. We're going to do this all over again. We're going to take this point. We're going to add our vector here. So I have 8 plus 3. That gives me 11. I have negative 1 minus 2. That's negative 3. And negative 13 minus 5 gives us negative 18. So there, these are all of the missing points. Okay. Right, 9b. So it says use vectors to determine whether this A, B, C, D, whether this is a parallelogram. Now if it turns out that these points make up a parallelogram, that means that of course the opposite side should be parallel. So, and they should be the same length as well. We're looking at the magnitudes. The magnitudes have to be the same size and they have to be going in the same direction as well. So I would argue that if I prove that the opposite sides are the same length, if I can prove that the opposite sides are the same length, then that should be evidence then that it's a parallelogram. So this distance here, well, I'll do one. So this magnitude here is head minus tail, so we'll take -1, 2, 4. We're going to subtract 5, 0, 3. That's going to give me -1 minus 5 gives me -6. 2 minus 0 is 2. 4 minus 3 is 1. Well, what's the magnitude then? What's the magnitude here? The magnitude is -6 squared, which is 36, plus 2 squared, which is 4. 36 plus 4 is 40, plus 1 is 41. I'm getting 41. Now, what's tasked to see if D to C also gives us D to C, whether that also gives me the square root of 41. So we're going to take head minus tail. It doesn't really matter which direction. We're just looking at the magnitude. So it doesn't really matter, as I said. So I'm going to take D as my head. So 10 minus 5, 5. We're going to subtract 4, -3, 6. So that gives me 10 minus 4, which is 6. -5 minus -3 gives us a +3, so -2. And then 5 minus 6 is going to give us -1. Well, I can see already that if I find the magnitude of these, I'm also going to get the square root of 41. So it looks compelling. It looks like this may be a parallelogram. So do the same thing with the other two, the opposite sides, to see if they are the same length. And if they are, then you have a parallelogram. Let's move on to 10C. The directions say, use vector methods to find the remaining vector of, all right, well, so let's find this vector here. This is a parallelogram, right? These little arrows here indicate that these two sides are parallel. These double arrows indicate that these two opposite sides are parallel as well. So I'm going to find this vector right here. So I'm going to take head minus tail, 3, -2, -2, and I'm going to subtract 0, 4, 6. That gives me 3, -6, -8. That's my vector. I'm going to take this vector and I'm going to add it to this point here to get this point here. So 3, so I'm going to add it. So I have -1, 5, 8. I'm going to add it to 3, -6, -8 to get 2. 5 minus 6 is -1, and 8 minus 8 is 0. So there you go. That is the point right here. Okay, wow, there's still a lot of problems left. I'm not progressing as fast as I would like to. In the given figure, B to C, from B to D, this distance here is parallel to O to A and half its length. So whatever A is, this is half of A. Find in terms of A and B the vectors expressed for, so I want to find the vector from B to D. Oh, B to D, well that's just 1/2 A. I want to find vector A to B from A to B. Well, that would mean that this vector has to be reversed and this vector here has to be reversed. Or, well, we could actually use these. We're trying to write in terms of A and B. So if I'm starting at A and I need to get to B, A needs to be reversed, so negative A and then plus B. B is going in the right direction. That would push me to B. Let's look at O to D. O to D. O to D would just be B plus 1/2 A. So B plus 1/2 A. And A to D. A to D. I would have to do that, I'd have to do the opposite of A. If I'm going from A to D, I have to do the opposite of A, minus A. B is going in the right direction, so plus B. And then plus this 1/2 A. So plus 1/2 A. We could simplify this if we wanted to. It'd also be true then that negative A plus 1/2 A is going to give me, so I'd have B minus 1/2 A. This would also be true. You have the same idea. I don't want to, well, the other C and D have the same idea, so I'm not going to move on with and do those problems. Let's look at 12C. 12C, I'm trying to, so I have this vector A to B, so some vector A to B. I have a vector from A to C. I have a vector from B to D. Doesn't really matter the direction, it's just a matter of just getting a conceptual understanding of what the directions of these arrows. So I want to find this vector from C to D. I want to take this vector from C to D. Well, in order to go from C to D, I need to reverse this vector here. If I reverse this vector here, and I'm starting here, my sailboat starts here, and I reverse this vector from C to A and A to B and B to D will take me to the same point as from C to D. So we're going to just add the opposite of this. So that's going to be, it's going to be positive 1, negative 3, negative 2, and we're going to add that to 2, negative 1, 4. We're going to add that to 0, 2, negative 3. So that's going to give us our new vector of 1 plus 2 is 3, negative 3 plus negative 1 is negative 4, plus 2 is negative 2. Negative 2 plus 4 is 2, 2 plus negative 3 is negative 1. So there you go. That is our new vector of 3, negative 2, negative 1. And my notes show that I have something different. I should have a different answer, so I'm just going to check the work really fast. So if we have A to B and A to C and B to D, then I really want to go from C to I want to reverse this one. I reversed the wrong one. So there you go. I reversed the wrong one. It should be negative 2, 1, negative 4, and then add these two. That's what we should have done. So that would give me negative 1, 3, 2, and 0, 2, negative 3. That would give me negative 2 plus 1 gives me negative 3. 1 plus 3 gives me 4, plus 2 gives me 6, and then negative 4 plus 2 gives me negative 2. Negative 2 minus 3 gives me negative 5. Yeah, my notes say that this should be the answer for C. Not this. I reversed the wrong vector. I should be a little bit more careful with that. All right, 13D. 13D, we're going to take C, which is 0, 1, negative 3, and we're going to subtract 1/2 of A. 1/2 of A is going to be 1/2 of 2 is just going to be 1. 1/2 of negative 1 is going to give me negative 1/2, and 1/2 of 1 is also going to give me 1/2. So my new vector should be 0 minus 1 is negative 1. 0 minus negative, that's a positive, so 1 plus 1/2 is going to give me 3/2. And then negative 3 minus 1/3 is going to give me 7, negative 7 halves. And there you go. This is my vector. So I don't feel like we really need to do a lot of these. It's stuff that we've really done a lot already. So I'm going to skip a lot of these so that we can finish the video. Here it says for 15, it says find scalars ABC. So we're just going to look at, so we have a scalar here. So this actually becomes 2, 0, 6a, and then this vector equals b, c, -1, and 2. So b, well, that's just 2. And then we have a, which is, well, if I have 6a equals 2, we can divide by 6. That's going to give me a equals 2/6 or 1/3. So a is 1/3. And then c, we have this 6 equals c minus 1. We're going to add a 1 to both sides to get that c equals 7. So, so there you go. This is at least our ABC values. So I don't know. I hope this is helpful. If not, talk to me in class and I'll give you some better direction.